So this one is question 6 from electric circuits, the topic block 4. Figure 8.1 shows a circuit. You can see a battery is there, a DC supply. There's an ammeter to measure the current, and a 6 ohm resistor is there, then a 2 ohm resistor, and then a 3 ohm resistor. And they are all connected in series. Why we say they're all connected in series? Because there's only one way for the charges to flow. So they have the same current. That's why we say they are connected in series. If they were connected in parallel, then they will receive the different voltage. Sorry, if they're connected in parallel, they will receive the same voltage but different current. But as they're in series, this total 12 volt will divide between them and they all will have the same current. So what is the ammeter reading? Same current will be there across each of them. The lamp has a resistance of 3 ohm. The line XY represent a uniform resistance wire of resistance 6 ohm. Calculate the reading on ammeter. So what we need the total current in the circuit. But before working out the total current in the circuit, we should know the resistance, the total resistance of a circuit, because V equals IR. So we have the formula V equals IR. So if we need the total current, the total voltage divided by total resistance of a circuit, we'll get the total current. The total voltage of a supply, that's equal to 12. But what about the total resistance of a circuit, as they are all connected in series? So if you want the combined resistance of a component or a circuit, they're connected in series, so we simply add them. So this will be 6 plus 2 plus 3, which is the total or the combined resistance is equals to 11. So the total current, it will be 12 divided by 11. What's the answer for 12 divided by 11? 12 divided by 11.
1.09.
So 1.09 ampere. So we write as a current equals to 1.09 ampere. That is a current which will flow through this whole circuit, as they're all connected in series to each other. Then the next part of the question, this is question number 6 we are doing. The next part, figure 8.2 shows a circuit with a different connection. Now you can see that for this circuit, what happened? Like we have a 12 volt supply, then we have 5 ohm, 2 ohm, and 3 ohm are like this 1 ohm and 0.6 ohm are in 0.6 meter length are in parallel, and then 2 ohm and 3 ohm resistors are there. So if I draw the circuit, it actually how it looks like, 1.5 ohm resistor is there, a wire which is having a length of 0.6, that is acting also as a resistor, and next to that is a 2 ohm resistor, and next to that is a 3 ohm lamp. This is 1.5, and there's an ammeter, and we have a 12 volt supply. This is actually how the circuit will look like. So calculate the resistance of a circuit. So if we know resistance and length are directly proportional. So when the length was 2 meter, the resistance was 6 ohm. So we can simply use a ratio to work out the resistance of a wire which is having a length of 0.6. Because we already have this. We already have this 1.5 ohm is there. This is 2 ohm, 3 ohm. But we need first this part. First, we'll find the combined resistance of these two and then just simply sum them to get the total resistance of a circuit. But what will the resistance of this 0.6? What is the relation between length and resistance? They are directly proportional. If you have a longer wire, they have high resistance as compared to shorter wires. So what we'll do, like example, it was 6 ohms when the length was 2 meter. But now what we have 0.6 meter. What will be the resistance? It will be X. X to Y is just a metal wire, but we are only using the part of it we are using from X to Q. This part we are not using at all. So this part we are not using. We are only using 0.6 meter length. So resistance and length are directly proportional. So if this total was having a resistance of 6 ohms. So 2 meter wire having a resistance of 2 ohm. So 0.6 meter wire will have a resistance of X ohm. So 2 is to 6, the ratio between the resistance and the length. So if 0.6 meter, this will be X. We just cross multiply. So X will be equal to 6 times 0.6 divided by 2. How we get this 6 ohms? Because that is already mentioned in the first part. They mentioned the resistance of this wire. In the first part, they mentioned resistance from X to Y is 6 ohms when we were using the full 2 meter wire. But now we are not using 2 meter wire. We are only using part of it. We are only using 0.6 out of it. So what will the resistance of this part? So it will be 0.3 times 6, or 3 into 0.6 you can also say. That is equals to 1.8, I guess. So resistance of this part, now we worked out the resistance of this part is equals to 1.8. So this is 1.8 ohms. Now we need the combined resistance of this whole circuit. So how to work out the combined resistance of the whole circuit? First, we find the combined resistance of these two, which are in parallel. So what is the combined resistance of these two? When two resistors are in parallel, it is a product divided by sum. So 1.8 times 1.5 times 1.8 divided by 1.5 plus 1.8. So whenever two resistors are connected in parallel, the formula to get the combined resistance of the two, that is the product of the two divided by sum. So 1.5 into 1.8 divided by 1.5 plus 1.8. What is the combine of these two? 1.5 times 1.8 divided by 3.3. What's the total?
Equals 0.8.
So this is equals to 0.81 ohms. Now, yeah, 0.8. Now this 0.8, 2 and 3, they are all in series because the combined resistance of these two which are in parallel, that is 0.8, this one is 2 and this one is 3. So what is the total resistance of the circuit? The total resistance of a circuit will be equal to 0.8 plus 2 plus 3, which is equals to 5.8 ohm. So 5.8 ohm is the combined resistance of this whole circuit.